You again. So it's now my pleasure to introduce Dr. Meredith Williams. She is the Deputy Director at California Department of Toxic Substances and Control, and she'll be sharing some of their work looking at new chemical evaluation tools for their safer consumer products regulations.
Great. I'm just going to ask, okay, I'm with it now. So thank you. I'm pleased to be here today to talk about the Safer Consumer Products Program. I'm not sure that many of you have tracked it very carefully. The regulations came out of a 2008 law, the California Green Chemistry Law, which was intended to address some frustrations of the legislature to address the fact that the chemical by chemical bans that were coming through the legislature were turning out to be ineffective, leading to regrettable substitution. They wanted to incentivize. They did a thorough analysis and looked at the incentives to innovation and looked at TSCA in particular and decided that TSCA wasn't the best framework to incentivize people for moving away from well-established chemicals, and also shifting the burden of proof to manufacturers. So there were a number of factors that went into the framework, and it ultimately became a much more precautionary approach. That law, as I said, went into effect in 2008, and then the regulations, the Safer Consumer Products regulations, went into effect in 2013. So it's been about 4 years since they've been in effect, and I'll very briefly talk about what those regulations look like, how they work, and just highlight some of the points of intersection between these new tools and the Safer Consumer Products decision-making process. So the Safer Consumer Products Program uses a four-step process to identify products for which a safer alternative should be identified. So the first step is, which chemicals do we care about? We used a list of lists approach. Thousands of chemicals are on that list based on the 23 authoritative bodies around the world. We associate those chemicals with individual products and decide which ones we think might have the potential for harm. And if we think there's a potential for harm, we turn to the manufacturers, and that triggers the third step. Only after we actually list a product chemical combination as a priority product in regulation do the manufacturers have to do what we call our alternatives analysis. One reason we use a slightly different terminology than the alternatives assessment that you may be used to is that it's more comprehensive. We're asking more of the manufacturers other than just straight up chemical substitution and a focus on the use phase. So on the basis of that analysis, the manufacturers come back to us, tell us what alternative they think has merit, and we decide whether we concur and then make a regulatory response on that basis. And we have a great deal of flexibility with regard to our regulatory response. We can say there is no better alternative, it can stay on the market, or we could say there needs to be some restriction in terms of the point of use, end of life, communication to consumers about what potential hazards there might be. We can also require green chemistry funding to look for safer alternatives. So we do have a number of options at our disposal, and I won't talk about the regulatory response anymore. I'm going to focus on those second and third steps, which is where the decision-making happens, both for us and for the manufacturers. In our case, what we're deciding is which products warrant listing and regulation, and in the manufacturer's case, they're going through a screening and deep evaluation of what potential alternatives should be pursued. Both the manufacturers and the department have very different constraints and considerations when they're making their decisions. So for us, as DTSC, we are faced with tens of thousands of consumer products which may contain potentially harmful chemicals, and that's a lot to start with. Although we always talk about the 80,000 chemicals, those 80,000 chemicals can be translated into Lord knows how many products. That said, the product ingredient data aren't always available. So we don't always know whether the chemicals are in the products. We can become concerned about an individual chemical and decide that we want to pursue that, but maybe we can't figure out which exposures and which products contain those chemicals in levels that we might be concerned about. The other challenge we have is with regard to exposure, in that traditionally exposure analyses have focused, for instance, in the pesticide field, on far field exposures, whereas consumer products are much more commonly near field exposures, and so that's something we've given a lot of thought to. For the manufacturer's part, they have a product. The product has to meet its requirements. They want to keep selling whatever that product's function is to consumers. They have established product design processes. They have very complicated supply chains that they have to depend on, and they, to some degree or the other, they may feel they don't even have control of their supply chains. And then fundamentally, if we're looking at who's designing products, there are very few green chemists out there. The standard chemistry curriculum does not require a lot of toxicology training, and that's the bare minimum, let alone actual green chemistry thinking. And they also have to think about the entire life cycle of the product. And these different challenges drive the decisions and drive where the points of intersection are for the new and emerging tools. So if we focus in on DTSC's decisions about which products to identify and prioritize, we have two principles in our regulations that determine whether or not we're going to prioritize a product. The first is there a potential exposure to the chemical in the product? And the second is whether or not that potential exposure contributes to or causes significant or widespread adverse impact. That's a very different paradigm than TSCA, than many of the other chemicals management and chemicals regulation frameworks than we're used to. Sometimes we translate this into may cause harm. Gives us a lot of latitude, a lot of discretion, and it also makes our decisions quite challenging. So I'm going to focus on the two aspects of this in a very high level, which is to say that for us, because the exposure piece is so explicit, yet we're not using traditional risk assessment, we're challenged to really look into this exposure. And so we're already beginning to look at the new tools. We're partnering with the Office of Research and Development to apply SHEDS HT to different product categories, to different populations, to really figure out whether or not we should be giving things given attention. For those of you who haven't tracked SHEDS HT, the high throughput exposure modeling tool, it is based on a simulation of what each of us or what a population goes through in day-to-day life in terms of where the sources of exposure are. It can identify which sources are most prevalent and therefore help with prioritization. Its goal is ultimately to begin to look at chemical mixtures and cumulative exposures, and it can really help us. We talked about, Carl Kraner talked about children and the particular sensitivity. It can break down, give us a little more insight into what those differential exposures are for those populations. Embedded within SHEDS HT are some elements of the product intake fraction modeling of Peter Fanke, Olivia Joliet, Tom McCone, and that's providing some interesting insight. Again, the differential population is quite interesting. They will take a chemical or take a product, a specific product, and break it down into adult females, adult males, children, and tell you what the different dose level exposures are for those different populations. And again, it's a model, so there are many, many assumptions, but if you're in the situation where you're trying to make a decision among tens of thousands of products, it can be really helpful to have a tool to zoom in on where the potential problems might be. Again, it's very rapid, high throughput, can give you a comparative exposures for products in the building sector or products in various sectors. So these are some of the exposure tools that I think, and there are others that are valuable to us. And part of the reason is that I do think that exposure is lagging behind some of the toxicity tools in terms of development. And there are also just many more data gaps in the exposure realm than you'll find in the toxicity realm, believe it or not. And therefore, these tools take on more and more importance to us. Another area that we want to look at is just themes that we see in the consumer product sector. We have a work plan in place. The work plan identified product categories. You'll see a number of them listed here, but not all of them. But building products, certain building products, cleaning products, personal care products. And when we look across those product categories, we start to see that certain chemicals show up over and over and over again. For instance, antimicrobials are getting used in all of those product categories, although in very different ways, but nevertheless, when you see these themes rise to the top, it gives you a reason to want to dig further. And so let's take the perfluorinated chemicals as an example. We've already begun looking at the entire class of per and polyfluorinated alkyl substances in carpets, rugs, and also in their treatment products, the aftercare, stain resistance, and water resistance. Some of those chemicals are very well characterized. Some of them are not. However, one of the lists that we reference is the California Biomonitoring Program's priority chemicals list. And that list, Science Advisory Group has decided to look at chemicals as classes. And therefore, it gives us the authority to look at chemicals as classes also. And in the case of the perfluorinated chemicals, there's a tremendously high potential for regrettable substitutes. We've already seen, for those of you who are tracking, for instance, the Gen X emissions in the southern part of the country, you can see that there is potential for harm as we move away from PFAS and PFOA, for instance. And this is where the non-targeted analysis, again, can give us a better sense of what's coming, or give us a sense of whether or not this class can be managed as a class. In order for us to list a chemical product combination, such as carpets with the perfluorinated chemicals, we have to make a case. And that has to stand up to a peer review process that's defined by the state as to whether or not we've met our regulatory criteria. And there are going to be data gaps when you're working at the class level, the chemical class level. And so we are going to rely on these tools, point to any information we can to give us a sense of confidence in how well those data gaps are addressed. Switching gears to the manufacturers. When the manufacturers do the alternatives analysis, their job is to answer very basic questions. Is it really necessary to have this chemical in the product for it to serve its intended purpose, or might there be a safer alternative? And that means that manufacturers are just asking a myriad of questions, including, where are the data gaps? And they're going to have to identify alternatives in the face of those data gaps. So these tools have the potential to help them. As I said, our framework is a little different than either risk assessment or just chemical hazard assessment. We're integrating exposure science, hazard analysis, and life cycle thinking, and the manufacturers are really having a pretty heavy lift here. And so it gives us a lot of latitude to think a little differently. We published some guidance on how to do the alternatives analysis last summer. And I will just say that one of the things we pointed to, one of the tools that we pointed to was OECD's QSAR toolbox, which has a great deal of potential to help the manufacturers look for alternatives and screen alternatives. So in terms of the decisions that manufacturers are making, the default process is a two-stage process. The first stage is a screening stage. And obviously, these tools have a very different benefit for a screening process than ultimately for a decision process. So in that second stage where they do that in-depth analysis and really have to figure out the toxicities of the potential alternatives, they may not be able to apply some of the tools in the same way that they would in that first stage. The other challenge they have is that we are asking them to consider quite a variety of endpoints. These are defined in regulation, and we just heard a talk about some of the ecological considerations and the development of more ways to characterize toxicity in the aquatic environment, and that's very important to us. I'm just highlighting these as an example of where it's very important to have enough endpoints to be confident and avoid those false negatives. So in order for us to realize the potential, the legislature wanted to accelerate the protections, to truly have a precautionary framework, and to spur the development of alternatives. We really can say that, that these tools are essential. Although they're not all ready now, we are going to push the envelope, I think it's fair to say, in terms of applying them, figuring out what works, what doesn't work, and figuring out where we go from here. I do want to give a little bit of attention to just general informatics and data mining. These tools, again, I don't think they always get considered when we talk about the new tools, but between ECHA's huge wealth of data on chemicals from the dossiers that they're starting to integrate into databases that can be mined. The non-targeted screening tools are not only valuable for telling us what chemicals are out there, they're starting to tell us what structures might be used for different functions. There's a lot of back and forth between the different chemical databases and the non-targeted screening libraries that I think are going to have a lot of value, especially when it comes to those alternative searches and really focusing in on the essential functionality. And then I've mentioned a couple of these other things, but I will say that the data sources also are coming from industry, coming from the regulatory framework, and it's going to be ideally very helpful to access those data and help inform our decisions. So with that, I'll just, I've already touched on some of the tools that have relevance for our decision making, and I'm happy to take any questions.
Great, thank you so much, Meredith. Is there anybody that has a burning question for Meredith before we move to the panel discussion? Yes, John.
Meredith, that was a nice talk. Do you have a part of your program where you discuss with the industry the decision-making process that you go through when you're trying to understand if there are potential hazards based on alternative assays or new types of information?
There are a lot of different points of stakeholder engagement. We do have a science advisory panel, or a green ribbon science panel, and that's a place where we talk about those things on a conceptual level. We haven't done, that group has been more focused on the alternatives analysis, and now that that's kind of underway, I think it's important to start to shift the conversation, expand the conversation so that we're talking to experts, which include industry experts, about the adoption of these tools. For any of the decisions we make about an individual product and chemical combination, we have pre-regulatory workshops that discuss our thinking, the basis for our decision. We publish that technical document that goes out for peer review. We get feedback on that. There's a public comment period on that. And so there are opportunities for input. And then I should say that the alternatives analysis process also has the ability for public comment. So when that final alternatives analysis report is submitted, that gets posted, less any CBI content, and that gets commented on.
So in terms of the confidence that one might have in some of what you're doing, especially on the exposure side, it sounds like you've got some modeling to predict what may be coming off of, say, a built environment ingredient or a product. Do you have any way to ground truth that? Are you doing extractions or any other way to test these models?
We are not at this stage. Right now, again, we're at the screening stage of where should we be putting our attention. And at that level, I don't think, we're confident enough that the information are in the realm of possibility for us to make a decision that something needs to go to the next level of evaluation. So, yeah, we're in a very different part of your upside down triangle. We're way further down.